Okay, so what have we done so far is what I want to look at, just to make sure that when we move forward, we do not forget what we've done earlier. So can anybody help me with this? We did Git a little bit. We did Maven a little bit. We did Terraform. We didn't do much, but we'll talk about it today.
AWS.
AWS, just a bit. We'll talk about it today. And then we did something on Linux, right? Shell scripting particularly. Is there anything else we did apart from this? These two are not much, right? But these are the primary things that we worked on. Shell scripting being the most important one, and that's the reason why I've asked you to order that book if you can. If you can't, just look it up online. When I say online, not Google, okay? Online means some book online. So you get some confidence. What I want you to really focus on when you come to shell scripting, I would have probably added Python in this mix, but I don't want to confuse you too much with too many languages. I want you to focus on conditionals, declaration of variables. You should know declaration of arrays and usage. You should know. And again, I'm not going to handhold on each of these. I'm going to help you on areas that you do not understand. Okay. Most of it, if not everything, Jyoti has covered quite a lot in there. Arguments to a program. Search for that. You should find it in shell scripting. So how do you pass arguments? How do you read all the arguments? Conditionals, we already said, this is going to be everything that Sojourner was showing, right? If else, if then else, and then switch statements. Then you'll have loops. So conditionals, loops, and then this should pretty much be the skeleton. Am I missing anything in here? I know I'm not trying to put SCD, awk, and all those commands, but from a skeleton perspective, Jyoti, do you think I'm missing anything? Jyoti, you there?
I think that's all.
That should be all from a construct perspective, right? And then
yes.
We have awk, we have SCD, we have grep, curl, wget, tr, cut, so on and so forth. The list could just go on. I mean, we have change mode, we have chwn. What was the other one?
The same one, chwn.
Yeah.
ch1.
Yeah. So the list could just go on. Move, copy,
command,
ls, right?
EFR.
What was that other command?
Free xargs.
Yeah, xargs. Right. So this list would just go on. This ones you can do when you need it. So if you have doing something, you Google and find out about it. But these are the ones that I want you to build your expertise on, right? How do you declare a variable? How do you use the variable that is declared? How do you find something within that variable? How do you declare arrays and use them? How do you get the first element of the array, last element of the array? If you want to go to the array, what do you do? All of that, basically. So this is basically the language construct that I'm talking about. And this is for everybody, right? It's not just for one person, it's for everyone over here. So please do spend some time on understanding this, because it's going to help me a lot when we go into Docker. Any questions in this? Do you want me to go word by word, command by command to teach you, or do you think you are confident enough to figure things out and then come to me if you have a challenge in doing something specifically?
I should be good on my own. Sandeep. We can go and figure out each of these commands.
Yeah, but if you, that's the reason why I'm asking you to order that book, because you need to have something that's going to give you a direction, right? Not just do randomly.
Right.
Because what stops you from Googling all of these things that I'm saying, right? I mean, you can just Google and find out all of this. But I want somebody to give you a direction. You should know about, so there are, after this, there are things that you should know. There is users, groups, permissions, files, and directories. You should know all of this, right? So how do you control permission? How do you create a user? How do you create a system user? How do you create a group and add users to the group? How do you create a file and assign an owner to that file for a specific group or user? How do you do that same thing with directories and files, directories? What are symbolic links? How do you create symbolic links? I'm not sure how to do this. If you follow that book, you'll have to follow that book basically. You cannot drop it and say I will do it later. That's where I'll have a challenge when I move ahead, because then you'll ask me what a symbolic link is. You'll ask me what a directory is. You'll ask me how to, something is not working, the permission is not right. You're going to ask me all of that, right? So I'm in two minds whether to sit and really spend some time to teach you all of this, or can I trust you to go through that book and come back with question and map what I'm saying over here to the book. If the book doesn't teach you this, then also you'll have to come to me and say, hey Samir, the book doesn't talk about symbolic links. Can you please show me what it is? Can I expect you to do that? Go through the book and then come back. Yeah?
Yes.
Yes, Samir. We will go through the book.
Okay. Because if I start teaching you, right, problem is you'll understand everything when I'm teaching you, but then if you go and don't practice it, right, you'll not be able to catch up. Neither do I. Okay. I know what the fundamental is behind it. If I really have to solve a problem, I have to Google. So I'll also Google. Right. I know awk solves the problem. Do I remember the syntax of awk? Probably not. Do I remember the syntax of SED? Probably not. I get confused with -i and -e most of the time. When I want to do with a file, I don't know whether I have to use -i or -e, which is okay. I at least know it. There is a way for SED to take it from input or take it from a file, right? And that's okay with you too. What I want, I mean, at the end of this session, when you complete reading that book, what I want is, given a problem, you should be able to say that, yes, with shell script, I can solve it. And these are the commands that I will have to use. That's what I'm expecting, not to know the syntaxes. If you know syntax, great. Like you have something like this, A comma, B comma, C, and I tell you, I want the second element. From there, you should know that, okay, I will use a cut. And then I'll get the second element and I'll give it to you. You don't need to know exactly how to do it, but you know, okay, I need to Google for it and find it out. Make sense?
Yes.
Okay. I would also add date command to it. That should be it. That should pretty much be, date is not even required here. Date can be here. Okay. All right. Let's go. Today, let's talk about Terraform a little bit and AWS a little bit so that you get. Did we talk about Terraform at all last time? I don't think so, right? Not much.
Not much other than those commands: init, plan, apply, destroy.
Sure.
And then, yeah, we went through the few of the main important key files:
Right.
Aws, variable, and main.tf.
Okay, good. So let's talk. Maybe you've already figured it out what problem Terraform is solving for you, right? Basically with Terraform, what we're talking about is we have a service. Let's call it as connect services. Maybe not. I'll call it as good services. Services, okay. I'm calling it as good. And good services basically exposes REST calls, right? I mean, Saujanya had sent something for testing curl, request and response, whatever. So this is something similar. Let's assume we have some services, and this allows me to create some infrastructure over here. Okay, so if you treat this as AWS, the good service is AWS. AWS allows you to create EC2 instances, security group, so on and so forth, which you do not know much about it, and it's okay that you do not know. Okay, at the moment. Most of the time, what we do, AWS is not the only one, right? We have Azure, we have Engine, GCE, so on and so forth. What is we go on, we log into the console, and then we start clicking the buttons around to create our infrastructure. The problem with that is, if you delete the infrastructure or something goes wrong with your infrastructure, you again have to go click the buttons and create everything. Okay, so there came a concept called infrastructure as code. So I'm not even coming near to Terraform as yet. Okay, I want you to understand this story first very well. So it said, hey, is there a way I'm creating a EC2 instance going and doing click ops? Click op is basically clicking buttons around and creating a EC2 instance, right? I'm doing that. Is there a way I can document this as code, and then whenever I need it, either it's this one or I want to create another new instance, I should be able to use this code and create it, so that even if something gets destroyed, I'm able to reuse that code and use it. Similar to what we do with Java code today, right? Why do we store a Java code? We already talked about last time about the distributed code management, so on and so forth. But leaving everything aside, the most important thing that we really want to do with it is manage history, right? We don't want to lose a word. We want to understand if somebody checks in something wrong, what was the state yesterday? We should be able to go in the past, correct? And that's the most important piece why we want to manage infrastructure as code, because if I want to add something new to EC2 instance, I should be able to do it. I should be able to modify it. If I don't want this EC2 instance, I should be able to destroy it, right? So on and so forth. And I should be able to manage this code exactly the same way that developers manages their code. That is, I will be managing it into, let's say, GitHub in our case, correct? So that's where this concept of infrastructure as code was born, and Terraform was not the first one that came into the picture. There was AWS came up with AWS Cloud Formation templates. Okay. They came up with AWS Cloud Formation templates, which is basically a JSON-based language. You write everything in JSON, the resources that you need, and your formation template. I mean, if you log into your AWS, you would see there's a service called Cloud Formation. So you would go there, you would search for your JSON template, which might be stored in S3. We didn't talk about S3, so don't feel lost. S3 is kind of a storage system, right? You store it somewhere and you pick it up from there, and then you run your Cloud Formation template. It will go and create all of the infrastructure that you are storing into your template. Okay, so this concept was born. And then the HashiCorp guy, HashiCorp is the one who owns Terraform. Okay, those guys looked at it and said, oh, lovely, they have such a good templating engine to create the infrastructure. But what's the problem? The problem is it can only create infrastructure in AWS. What if I want to create infrastructure in Azure? Azure has a ARM template, basically, Azure Resource Manager template that allows you to do that. Google also has its own templating engine. but each one has their own templating engine to create infrastructure. So what it means is if Samir wants to create something in AWS, he has to learn AWS CloudFormation. If I have to create something in Azure, I have to learn ARM templates. If I have to go to GCP, I have to learn their own templating language to create it, right? Which is problematic. I'm going to stop here for a second just to make sure that I'm not talking to myself. You guys are able to hear me?
Yes, Samir.
Yes.
Okay. Interesting story so far. Are you able to relate?
Yes.
Yeah, interesting.
Okay, good. So now they said, oh, you know what? Let's do one thing. Let's create a generic templating engine or templating system, which could be used to create infrastructure across the platforms, across the cloud vendor. So if a developer knows, and let's name it as Terraform. If a developer can, if a developer can learn Terraform, he should be able to create infrastructure on all of it. But wait, how am I going to create infrastructure in EC2? I mean, not EC2, AWS and Azure. And let's say Google, GCP. How am I going to create infrastructure? So they said, okay, perfect. These guys have REST services. Each one of them has their own REST services. So REST services allows you to create infrastructure. So if you really look at what CloudFormation template is doing, right? Either it's a CloudFormation template or coming through a web console, all of them actually goes through this REST service. They have a service layer. They're not doing, they're not having let's put it in a more layman way. If I want to cook coffee or tea, I'm not going to go and make my coffee on a stove in my home, and then to make tea, I'm not going to go to my wife's home to make coffee and tea, right? I would prefer to have one gas stove on which I come and make it. I mean, it's a very weird example, but just to make it funny and so that you're able to map it in your head is what I'm trying to get to. Is you'll always have a common place where you'll come and cook. So your gas stove is the least common denominator when you want to cook. Similarly, when you want to create infrastructure, the least common denominator in any of the services is REST service. They have their own services. They expose the services out to the world and they also consume it. So just to give you an example over here, CloudFormation template also will use these REST services. Web console, when you do a click ops, eventually when you do a submit to create the EC2 instance, that also will use the REST service. And if you have a CLI based AWS CLI, that also will use these services. So they said, awesome, there is a service available. We will write a provider that talks to the services and we will call it as AWS provider.
Is our provider any
I will send it to you just a second.
on top of it?
Yeah, I'm sending it.
That's that's two U's that are connected.
Okay, wait. I'm sending it. Hold on. Go, you can go now. Sorry. All right, so they said, okay, let me write a provider, which is AWS provider. Okay. This AWS provider talks to the REST services that is provided by AWS. And this provider does nothing more than CRUD. Anybody knows what CRUD is?
No.
CRUD is create, read, update, delete. So if there's a resource called EC2, if I want to create it, I will have a resource EC2, and on this resource, I would allow you to do create, read, update, and delete. Read is basically if it's already created, you want to read about it, that's when you'll use read. You already have an instance and you want to make a change to it, you'll use update. And you already have a resource and you want to drop that, you'll use delete. Okay. That's the whole idea about it. Then as soon as they brought that idea, they said, okay, let's go ahead and create for Azure also. Let's go create for GCP also. So these are called providers over here. The providers talk to the actual REST service provided by those providers. Okay, and these guys provide a fluent interface for anybody who wants to create a resource. So what I mean by fluent interface is your resource always starts with resource. Right? So irrespective whether you're writing for AWS or as soon as you have your provider in place, and now you know for AWS, probably it is going to be AWS _ instance. That will be that Z. For Azure, it might be completely different name. For GCP, it might be completely different name. But the overall structure of how you create the resource always remains the same. What does that mean? That means if you learn once, you can apply that same logic for any other provider. It will not be the same resource type. Z is the resource type basically, right? But overall structure remains the same. If you want to read something from something that's already existing, you know that it's always going to be data. Always this structure. You want to loop through, you want to use functions. There are so many other things in Terraform which we will go in as we learn about it. But primarily, do you understand where I'm getting to? There is provider which talks to the REST services. We don't know about it. The only thing that we do is we declare a provider in our file, right? In the version.tf or the provider.tf. And that name also can be anything. It doesn't have to be versions.tf. It is just standards, right? We declare it, we initialize it. When we initialize this provider is downloaded from online, okay? And then what we do in our .tf files is we declare our resources. So far, is the story making sense?
Yes, sir.
Nothing.
Yes, clear.
Right?
Very interesting. So it's similar to Terraform. Is there any competitor who provides flexibility?
Yeah, all of these are competitors, right? You have CloudFormation template, competitor. Azure,
No.
ARM.
No, what I meant was, is there a competitor to Terraform which provides a flexibility to provides a generic template?
Terraform is the most matured tool, but there's Plumi. Let's see.
Lumi?
See, Plumi.
Plumi.
Yeah.
Mm-hmm.
So there will be some more, I'm pretty sure, but Plumi and Terraform are pretty much neck to neck, but Terraform kind of beats it in several reasons. The paradigm is different. Plumi does it in a different way a little bit. Terraform does it in a different way.
But at the end of the day, I think they must be invoking those REST services from each of those providers.
Everybody would always go to REST services, irrespective of how they do it. I can write my own engine basically that talks to all of them, and I can completely change the way Terraform does it, right? If I wanted to. What Terraform does is nothing great. It allows you to do a CRUD for every resource, and then it allows you to manage a state. So if you really look at it in the story is not over, right? I mean, we talked about REST services, we talked about cloud vendors, we talked about providers, we talked about CRUD operations, we talked about resources, we talked about data, but there's also one more thing which is called state. So when you run your apply, Terraform apply, you would see there's a TF state file that gets created. Terraform.tf state file. That state file basically captures two things. One is whatever is created in real world. If a EC2 instance gets created, that is called current state. Okay, and whatever is there in your TF file, okay, in your TF file is called desired state. Current state can be equals to desired state when you run it for the first time. Okay, when the resource gets created, and then you go and make a change over here in your TF file, that's when the desired state is different from current state. Okay, Your state file, your TF state file actually tells you what is the current state minus the changes or plus the changes that are done over here. So what I mean by that is when I do a Terraform apply, this resource gets created. That resource has some metadata. That metadata is captured over here. But after that, somebody goes and makes a manual change over here to it. So what does that mean? That means it is exactly TF state plus the manual changes that you've done. Okay. And since Terraform manages it, there's a command to tell, get me any change that might have happened over here from the time we applied last. And that's the command called Terraform Refresh. Okay. It'll tell me if there's any changes done there. So far, I want to stop somewhere here because I've given you quite a big picture, but I just want to understand if you have followed so far.
Yes, Samir. After running the Terraform refresh, yeah, if something is more in the current state, how can we update that in the Terraform script? I mean,
So,
if we run
Terraform never allows you to make a change that it is not managing. If there's a EC2 instance that it is managing, and if you go and make a change to it, and next time when you try to apply, it will always try to bring desired state to the current state.
Yes.
Okay, so what it means is you cannot go, if there's a EC2 instance that is being managed by Terraform, and you go and manually change something, the next time when you run Terraform apply, it will overwrite your changes. That's what is called a drift. If you really need that drift, you have to make sure that that drift is recorded over here in your TF files, because your TF files is supposed to be the source of truth. Does that make sense?
Yeah.
So technically, the expectation is you'll never make any change manually. And that's a big challenge. What teams really face is 50-50. They manage something by Terraform and something by themselves. But as soon as they start doing something by themselves, you should stop using Terraform, because as soon as you run Terraform, you're going to whatever you had done. Right? So that's why, at least in the current organization that I'm working on, we manage everything to Terraform. If I have to change one word over here, if I have to change a security group over here, I make sure that it's documented in my code. Clear so far?
So Terraform or Terraform refresh command, does that gets executed automatically, or we have to run it manually, Samir?
It gets executed every time you do a Terraform apply. But if you wanted to just get the state, the current state into your state over here, so that when it runs a Terraform apply, it would know what the difference is. Right? Not following?
Following.
Okay. All right. So in general, with what I have given you for Terraform, right? We will probably go into the depth of it, but before I go there, I wanted to talk a little bit about AWS. Okay. How familiar are you with AWS, everyone over here?
Zero knowledge.
Okay. So with AWS, right? I mean, again, there's a story to it. I usually like to tell stories when teaching because it becomes a little lighter, not too much heavier, right? I mean, how did we have the older world? Older world, every office used to have their room for data centers, and they would bring in servers and store in those rooms, okay? For example, in Xenmonics, we had an office where there were servers kept. And then what they had was they had a hypervisor called virtual machine or VMware, basically. VMware. Okay. And VMware allows, it's almost similar to VirtualBox. If you guys have used VirtualBox, VMware allows, with all the resources that you have, it allows you to create smaller servers, which is almost similar like to your machine basically that you're working your laptop. So it has its own operating system, so on and so forth. And VMware takes care of assigning it resources like the hard drive, the memory, CPU, so on and so forth. So basically you're sharing, although you had just 2 servers over here, you can create 10 virtual machines if you need to. Okay, that's how it was being managed. And think about it that every single person, every single office, this is how they're doing it. And to go to the internet, they have one single link that takes them to the internet, right? Because they need to download software. Your developers need to access the systems and whatnot, the software from the cloud, right? I mean, that's what they do it. But now with AWS again, what AWS said is, hey, you know what? Let's build a big data center, a very big data center. And people would not have to host this on their in their room, in their building, so on and so forth. They can just come to us. Okay, there was another problem with this particular thing is if you wanted to bring in a third server, you had to put in a request. The dealer will take its own time, 2 weeks, 3 weeks to get you a server. So now what happens is either you had to stock up servers even before you need it, or you had to take a beating that I already have a requirement, but my clients have to wait now because the vendor takes 2 weeks to bring the server. So that's the problem that AWS tried to solve is, hey, you know what? You can come and ask for the server anytime you need. I will give it to you. I would be the one, and you only pay me for what you use. If you don't need something, just release it. I will not charge you for it. So total cost of ownership, or TCO, what they call it, considerably reduced, right? Because you would only ask for it when you really need it, when you have business. Otherwise, you'll destroy. Like the same way what I told you earlier, right? Use Terraform destroy every time you run your commands and you have tested, backed up everything that you need to back up. Just destroy it. That's why I give you Terraform, right? And whenever you need it, just do a Terraform apply. It will create the resources for you. Okay. Now, since we started talking AWS, let's talk from a global perspective, right? This is, if you assume this is the world. In the world, what they did was they went in and they created regions. Okay. That's what they call it as region. So Asia Pacific could be one region, US East one might be another region, West one might be another region, so on and so forth, right? And then Australia, you have another region. They have several regions across the world. Okay, what does a region, what does data center in region really get you is, if at all somebody goes and nukes a country, or there's a natural disaster that happens, the whole country goes for a toss, loses its internet, and you're not able to do business anymore. So nowhere around the world, whoever was going to this data center in India, they are not able to connect anymore. Whoever was doing business with the servers over here have lost, right? They didn't want that. So they wanted like completely distant servers. So what normally people do is they set up something called as disaster recovery. DR is what they call it. They will keep the servers over here, which are primary in India. They would also put it in a different region, which is either kept active, that means both of them will be working, or it is kept active passive. That means this one, they will never bring it up unless and until they really need it. Okay, but they always do a DR exercise. So if you go in any organization, they would say, oh, we are doing DR exercise. What does that mean? That means they will try to blow this up or say, stop using this and let's go and use this and see if it is workable. Because you just cannot sit and say, oh, you know what, I have another application in this server. This application in the server might be 5 years old. You want to make sure that the data that is written on the database is being replicated on the database, which is sitting over here. And the applications which are deployed over here are matching, or you have the capacity to bring these applications and deploy it on this particular side of the world. So is the region clear to you? Why do we need region? From a cloud perspective, this is not only AWS, okay, in general. Is that clear?
For
Yes,
a
sir.
backup purpose. So the synchronization happens constantly, Samir, or it
No. All of this is your work. Nobody sets up disaster recovery for you. What AWS gives you is AWS gives you region.
Okay.
Now you go and create your EC2 instance over here and just work in over here. I think most of the time when you're creating in US East 1. So look on the top right corner, there are
Yep.
regions, right?
Right.
So you must be doing it in East 1, North Virginia. That's the by default one, if I'm not wrong, or Ohio, I don't know. So if you deploy a EC2 instance over here, if you wanted to have a disaster recovery for your application,
Hello.
because it's very, very critical, you'll also create it over here. Okay, you'll have in both the sides. Now, if your application was writing to a database, if you had an application in that EC2 instance, data, if at all this blows up, it blows up with everything, right? Your data also is gone. So usually what people do is they also create a database on this side and they set up a replication. They do it. AWS doesn't do it for them unless they're using a service that allows regional replication by default.
Mhm.
Okay, so nobody's going to ask you to do all of this, but it's always good to know when you go in. Let's say if you get in and start learning AWS in depth, you'd probably get here. But anyway, let's go back. So you have region, and in every region, they have, let's say, at least 2 buildings separated by just some time, but most of the time they're sharing. They are not sharing resources. They are not sharing electricity, but they are not so far that you can call them as a region. So in a region, you can have 2 to however many availability zone. That's what is called availability zone. AZ. Right? Okay, I'll stop here. Region and availability zone. Is that clear?
Yeah, clear, Samir.
So many a time what people do is they deploy it in multiple availability zones so that if one availability goes down because there was no electricity, which is local, they will at least have the application running in the same region on a different availability zone. Okay. So that is basically.
This is like setting up a disaster recovery, but within the same region.
Yeah, I mean, they don't call it as DR normally. It is highly available application is what they call it, HA, usually. Because that's disaster is basically when things, so these buildings are so close to each other, they might be just step away. So if at all there's some disaster, natural disaster, expectation is both the buildings will go down, maybe. But if electrical connection stops for one, or the AC stops working in another one, it's very unlikely that the AC will stop working here too. So in that way, you still have high availability when one of them goes down. But yeah, from your perspective, you're right. If we consider this as similar to region, then you're setting up disaster recovery, right? But most of the time, we can create subnetworks, multi-subnetworks, and then deploy our application. If we have 2 VMs, we can distribute them across 2 VMs. To availability zone, not VM, sorry. Give me 1 second. Any questions? No?
No.
Okay, good. Let's now go. And again, don't take me wrong. We are not learning AWS in here, okay? I'm showing you things so that we can go in each and every one at a later stage, eventually in a couple of sessions down the line, okay? So let me go back to this document over here. So we did talk about Terraform. Romana, tell me.
Yes, I mean, when we were talking about the Linux command topic, right, you mentioned knowing Python. Is that required?
Knowing Python is good, but I will not press for it right now.
Okay.
Right. So we are coming close. The next that I want to really, I mean, first of all, I want you to when do we have the session? Saturday, right? Before Saturday, I want you to finish this if possible, because what I want to go for next is Docker. We want to talk about Docker, and we want to be able to create multiple containers inside Docker. So in Docker, we're going to look at images, containers, networks,
Volumes.
so on and so forth. What's that?
Volumes.
Yeah. Volumes, networks, images. Yeah. There might be more that we will look at basically eventually, but I would not go for Docker Compose and Docker Swarm. Not at the moment. I will probably give you a reference if you have to go learn more about it. Even for learning Docker in depth, I will give you a reference, what you need to do. Okay. But I want to complete Docker as soon as possible. And then I want to install Jenkins. This is a question that I had asked Jyoti, you didn't answer me. Have you installed Jenkins?
Yes, I have answered you, Samir. Yes, I have
really?
installed it, and yes, you somehow you missed it. I have given reply.
Yeah, I really didn't see that. Okay, anyway, I'm asking you.
I have installed it and I have played it earlier.
Okay, and you installed it as a independent instance, or did you install it using high availability? HA.
Independent Jenkins.io directly
Yeah,
going to the
so you just went to the EC2 instance and installed it, right?
yes, AWS EC2 instance. I have
Okay,
installed.
so that is basically non-HA, which is fine for now for us. So we already have seen EC2 instance. We would go ahead and install Jenkins, and what we will probably do is we'll have a Route 53 domain for each one of us if needed. Or how do you want to do it? Do you really care about installing Jenkins, or do you want to use the Jenkins instance that I can install in my account? Because if you install Jenkins and start using it, it'll incur some cost to all of you. Instead of that, can we? What's that, Romana?
In AWS, you mean? I mean, if we install Jenkins.
Yeah. I don't want to do anything on local instance. The reason being, that is good for you to learn when you're just starting, right? But eventually, when you look at it, when we collaborate, all of us, that is, I'm trying to bring it to as close to reality as possible, right? So we would want to, if you want to just go and install it in a virtual box, I'm fine, but I don't know how much it will sustain.
So about the cost, how much is that going to be? Something like from the if we have to play around to know more about it, then we may need access to it, right? And so how much of cost we are talking about?
I don't know. That's what I'm saying. Nobody is ever going to ask you to install Jenkins, right? If you want, you can just install it and then destroy it. But for us to use it continuously for our training, I would potentially install it in my account. I mean, definitely it will cost me money, but at least it will not be, not all of us will be bearing it at the same time, right? I mean, I'm also spending on Jenkins, you're also spending on Jenkins, so on and so forth. So we all can sit together and we can install Jenkins as part of one session. And then the only thing that we will do is we will use that Jenkins instance to create the jobs.
Sure. I think we all can share the cost if you're okay with it. And that is just to show how to install Jenkins in AWS, right? And for our practice purpose, we can have local instance that we can play around with, right?
Yeah, I mean, The thing is, we are not going to finish up learning Jenkins in a day,
Okay.
right? We'll be spending quite a lot of time over there. That's your magic ground, basically, which
Mhm.
basically ties you to Maven, Git. Everything that we are doing is to come to Jenkins,
Okay.
right?
Finale.
So it's not like something we will create and we will destroy. We will keep it there for at least a month until you guys are able to play with it, do everything that you have to do. You know, we'll be spending a lot of time on Jenkins, and I'm waiting to get to Jenkins because after we get to Jenkins, that's when we will deep dive into each of the other tech that we've looked at. So we probably will also have Nexus remote repository.
You also take few classes on JFrog.
Yeah, we can do JFrog. It's primarily almost the same. The only thing is JFrog. I don't know JFrog gives you a community edition. We will have to spend money on it if you have to really go there. So JFrog only gives you a SaaS solution. They might have some free community open source. Let's see. No, I don't think so. They're giving JFrog for free. You know what I mean, right?
What is that for, Sami? JFrog?
JFrog is for storing your Maven artifacts remotely so that multiple people can collaborate.
Oh, right. Yeah, local repository versus report.
Yeah.
Right. Yeah.
Yeah, so it's a remote repository.
And while you were listing the topics in the beginning, right, you asked us to remind you about Postman.
Yeah, Postman would be just to make REST calls, basically. We can come to that. You would eventually need it, but maybe later. Since you're going to be using curl and wget command, right? You can do most of it using curl and wget command. Curl command primarily.
Okay.
All of your
And
REST
then-
calls.
Got it. And then you also listed Sonar Cube.
Yeah, Sonar Cube will be more for scanning the static scanning of code. So that also we can wait until Jenkins is done. Anything else that we had there?
Let me just go.
Yeah, so we have to do something to come to Jenkins very soon. Like we have to complete. I'm expecting that you will complete your Linux and have a command on Linux.
Helm file. What is that?
No, that will all come later.
Later.
What we're trying to do until here is this is the CI part, continuous integration, right? Then we will be talking about Kubernetes and Helm, so on and so forth. But we'll be spending quite a lot of time just talking about continuous integration, that is building and producing artifacts, be it a Docker image, be it a Maven artifact, and storing it in a remote repository. Nexus or JFrog doesn't really matter. They almost do the same thing. Okay. So I cannot complete Docker in one single session. Same way I couldn't have completed Maven in one single session. But since I wanted to give you a paradigm view of the whole system, right? I had to rush fast. So when we read Jenkins, we will potentially have to spend some time in Maven, sometime in Terraform, sometime in Git. I think Git we have covered quite a lot. Are you guys comfortable with Git? You should be working with Git day in and day out now with your Git repositories.
Yes, sir.
So do you feel there is anything else that I should have covered in Git? Jyoti, as part of your work, are you able to do much of your work using Git? Whatever,
Yes, sir. Yes,
or do you
sir.
feel any challenges?
Can we clone multiple repositories at a time? Is it a good idea?
You can, but you'll have to write a shell script and write git clone command in that shell script, multiple git clone commands. So now you know shell scripting, right? create a shell script, add a shebang, and then write git clone and the URL on one line, then come on the second line, git clone and the new URL, so on and so forth. And now just run your shell script, execute a shell script. It'll clone all of those repositories, what you mentioned over there. Make sense?
Yeah.
Okay. I used to do that, especially if I have like 10 odd repositories. I would just write a simple shell script, and I would also give an option to pass in parameters. So if I pass star, it will clone everything. If I pass the name of the repository, it will only download or clone the repository that I need. So that could be assignment for you actually. And that's where I said, I'm not giving you a specific assignment, but feel free to be innovative, and really understand the Linux world. Okay. All right, so we are just very, very close. I know there are other things that we want to really learn, but we really have to spend time on Linux, and we really have to spend time on Docker. The Docker, we will go ahead and install Nexus in my AWS account, and I will install Jenkins in my AWS account and front it using my maybe a Route 53 domain, so you can connect it. And we can start playing with writing Jenkins files, so on and so forth. So who all is familiar with Jenkins over here so far? So Jenny, are you familiar with Jenkins, or you've never used it?
I know basics, Samir.
Okay. So you have installed Jenkins and you have used basic jobs?
Yes. Basic
Okay.
job. Yeah, I did CI/CD. Yeah.
All right. So yeah, I mean, as soon as I get to this is when I would start getting into cost, and then we will see how much cost it really comes in. If it is under tolerable, we can probably keep it running, or we can keep it running only during the daytime, and then during the night we can bring it down, so on and so forth. We can do that. So one of you will have to take care of shutting it down. We'll see.
I think it doesn't take much time. We can install Jenkins, Java every time. Every day.
No, if we do every day, right? What I will have to do is probably I'll have to keep the configuration in place, right? Because you'll be creating jobs and so on and so forth. I don't want to lose those jobs. So what we will do is maybe we will do it the same way. We will not create any freestyle jobs. We'll keep everything in the code, the Jenkins file. So we will create Jenkins instance. Yeah, I think that's a good idea.
Yeah, we keep all the Jenkins files in GitHub repository.
Yeah.
With the help of that, we can easily create the jobs.
Correct. Yeah, we can do that. Yeah, but we'll have to spend at least some time to show everybody else how to write freestyle jobs, right? Maybe one session we can do it and then destroy it, and then keep everything in Jenkins files, because that's what is going to be used in the real world anyway. Yeah, that's a good thing. Okay, open to questions so far. Any questions? Yeah, today was a little lighter session. I believe we didn't go too much into details. Did you want to learn Docker today, or you want to learn Docker from next session? Let me capture some notes over here. Give me 1 second. Okay, create the VM, call Docker on the VM. Has anybody installed Docker earlier?
Yes, Samir.
Yes, I did too.
Sure. On EC2?
Yes.
Yes, EC2 instances.
Yes.
I usually like digital. Let's see if they have something. Yeah, there should be good one for you. APT is for Ubuntu, basically. That's not for CentOS. And if you install CentOS, you want to look at yeah, it should be hopefully good.
I think there is one simple call command with that we can easily install Docker.
What's that?
One simple curl command is there. With only one command, we can install Docker.
Do you have that command?
Yes, Samir, I will provide in the WhatsApp. I will bring it later.
Okay. Yeah, most of the time when I installed it, I had to, especially with Amazon, right? Yeah, take a look. But
Even I
will,
use these commands only, Samir.
what's that?
Install.
This
Even
command.
I use those commands. Yeah, sudo commands.
Yeah, yeah. I would suggest go with this because it talks about groups and all that, and that's why I wanted you to spend some time with the Linux book, right, to understand groups and users. Otherwise, you might think, why am I doing it this way? Yeah, you don't need to do any of this. You just have to install it and then do a Docker info. If the Docker info command works, I think you should be fine. And then everything else below here, we will learn it as part of a session. If you want to just go ahead and do it, I'm fine. Don't need this. This two is enough. So in the next session, we will talk about Docker. We will create simple Docker file. Work with it, create image from Docker file, create container from image, stop container, delete.
Yes, Amit, just I shared the curl command to install Docker.
Sure.
Copying the curl command. With that command, we can simply install Docker.
Yeah, get docker.com. I don't know which version you will get with that, Jyoti, whether it will have latest version or not. Yeah, try it out. If it works, great. All right, delete images. Docker container and its volumes. So some of these things we're going to see. I mean, most of it should be simple, and then I would probably give you some reference. Everybody uses Udemy over here?
Yes, Samir. I do.
Okay. Anybody else who
do,
doesn't
yeah.
use? So everybody uses Udemy, right?
I do, yeah.
Okay. So there is this guy for Docker specifically. If you want to prepare before you come to the session, and if you've never done anything with Docker, Docker Captain by Brad Fisher, something like this in Udemy. He has done very good justice to Docker in my view. He goes to pretty good depth of learning Docker, and Docker is something that you really have to know very well. Just Docker, okay? No Docker Compose, no Docker Swarm. He goes into those details also. But just Docker, if you have to know like in depth, he's the guy that you would want to go to. Okay, but most of it we will cover. The only thing is in one session we'll not be able to cover everything, and you want to kind of go ahead of the sessions and know it in depth. That's where you want to go. All right. In terms of certification, like, is anybody over here planning to do any kind of certification, be it Docker or Kubernetes or any of those?
So far, no plans, Samir.
No planning so far.
Okay. Yeah, I mean, as we are moving ahead, right, you might want to plan for it because it might help you to get into a job very quickly. That's the point, right? Be it AWS certification or what will happen is this, right? I'm not going to the depth of it. And when you start preparing for certification, you might probably have questions, and I'm available for you to come and ask me questions about it. So, and since we are working all in group over here, you'll be able to motivate each other that, hey, you know what, I'm doing AWS certification. Do you want to do it with me? So think about it. That would just help you shine your profile, basically, your resume.
Can we also get certification in Jenkins and OpenShift?
There is a certification for Jenkins for sure. For OpenShift, the certification is very expensive, so I would not recommend. I would just say take a certification for Kubernetes. For OpenShift, it was like $2,500 when I looked at it last.
Oh.
It doesn't make sense to me. The Red Hat certifications are always expensive, right? So I would suggest do a CKA, CKAD, CKS. So CKA is Certified Kubernetes Administrator, which I have done. CKAD is Certified Kubernetes Application Developer. I have done that. CKS, Certified Kubernetes Security Specialist. I haven't done that because that certification was not even there when I went for the certifications. Okay. And AWS, I would suggest you can take up AWS Cloud Practitioner if you've never done AWS at all, or you can take up AWS Solution Architect. But it will take a lot of effort to prepare for it. So if you keep it for later, it's fine. You know, just focus on what I'm teaching now. And by now you should have probably realized the pattern of teaching that I'm taking into consideration is showing you a big view of the whole platform, right? I mean, if you don't know the whole story, no matter how many times somebody tells you a corner of the story, you'll never understand it. For a moment, you'll feel I understand it. And later you'll go and say, oh no, I don't understand this. So my pattern of teaching is a little different. I don't know whether you like it, you don't like it. But I'm trying to take you to a level where you tasted everything, little of everything, and then we'll go to the depth of it. Okay. With Maven, I don't know whether you've spent time creating your own plugin. Jyoti, I know you had a trouble. I had sent you a response back that you were doing it wrong. Please do spend some time if you want to gain some expertise on Maven. Don't take it lightly. Okay.
Yes, yeah, sure.
Okay, we have some more time, Jyoti. Do you want to? I will